5 for Physics 2211, so let's get started. So for the capstone project, I selected the Slinky as my option for analyzing. And so in lab 5, I analyzed the Slinky falling, or spring falling from a set height. And the purpose of this lab was to find differences in my experimental and glow script code model. So the main physics principles I used were Newton's second law, which states that F net equals ma, and the position update formulas. And so the final result of this lab were that both graphs, the experimental and glow script, were very similar, with the experimental graph values being slightly below the coded values. So here's my video, or this is actually just the diagram of what happens. So as you can see, the Slinky stays in the position as the top of the Slinky moves down. So there's two stages. One is the Slinky, the top of it moving down to the bottom, and the next stage is when it starts to fall down to the ground, which you will see later in GlowScript. So, but first, our initial conditions in GlowScript. Here is the ball's mass, which I just estimated with the size of the ball from the video. Then this is the initial position from GlowScript. This is also from GlowScript, the delta t. This is the acceleration of gravity, and this is the proportionality constant that I found using just trial and error in GlowScript. So systems and surroundings. So the spring is the system, and the surroundings is the drag force, tension force, and gravity. Or should I say the surroundings are just the drag, the tension, and gravity, because they act as forces on the spring. And so in Newton's second law, this states that F net equals ma, but in this case, the F net for the first stage, where the Slinky is the top of the Slinky is falling to the bottom, that would be the force of tension plus the force of gravity, because the force of tension keeps the Slinky up as the force of gravity acts upon it, which keeps the bottom of the Slinky in place. So they average out to be 0 in the beginning, the force net. And then the force net in the second stage, is the drag acting against the force of gravity. So that's once the spring starts falling. And then so the position and velocity update formulas. So in order to find the position after we found the net force, right, we first have to find the V final, and then from there we can plug it into the position update and find the positions. So that's right here. And in both stages of the GlowScript code, this is what I used to calculate the positions. So the final result is that the disparities in experimental and GlowScript could be due to differences in maybe the wind at the time of experimental recording, which would have kept the Slinky in the air longer, which could have slowed down its fall, right? And so the wind could have either slowed or increased its fall. And in this case, it increased its fall, as you can see, because it's moving faster than the GlowScript code, moving down faster. So possible sources of error in this lab were just the tracker points were not plotted accurately or consistently in a straight line down. Thank you.